And that's hello. Hello, how are you?
Good, how are you?
Griffin. Okay. Dollar. All right. Tonight I want to show you what is due this week, and then we go from there. So this week, the assignment that I do this week 16, includes, first of all, the reading for the week is chapter 9, test of hypothesis. Then the assignment, we have classwork 13, which I will put in after the class. Have homework 9 and the final project. Now give me a minute. Let me send a message. A lot of people have not joined yet. Give me 1 minute. Let me send this message. Okay, mind. Okay, I think they are joining, so I can just cancel this. They're joining now, so I have to. Who is Jadine? What's your full name? Jadine, what's your full name? Jadine? Can you hear me? Who is Jadine? You can just answer me. I don't text. We're in the classroom. Tell me your name so that I can mark you present. All right, let's continue. Classwork 13, homework 9, and then your final project. Your final project is actually due on the 17th, but I want you to start working on it now so that you will not get caught up, so you can finish it on time. So the project is located, if you go to the assignment section and scroll down to where you have the Excel assignments. Matter of fact, the project is part of the Excel assignments. And this is it right here. If you click on it, it can download it from here. So yeah, download the project from here. Where is a Word document. Download it, type inside it, finish everything. Then when you finish, you can then upload it here as well. From your end, you will see where you're gonna upload it. The final exam, I will open it up for you next week so that you can take it. Now, let's begin. Any question before we start? Any question? Yeah, no question. Good. Let me create more room. All right, I'm gonna share my screen. So today, what we're doing is test of hypothesis. We're gonna do a test of hypothesis today, and next week we'll do regression analysis. The test of hypothesis we'll be working on. We just do for one sample. And what is hypothesis testing? Hypothesis testing is a claim about a population parameter. And this claim may be true or false, but we have to test the claim to figure out whether it is true or false. So when we say population parameter, we're referring to mean, standard deviation, proportion. For this class, we'll be using the mean, testing for the mean only. We will not have time to do this test for standard hypothesis testing for standard deviation. So now in hypothesis testing, we do the following. We define the population and specify the parameter under study. Then we state the hypothesis. Okay. We state hypothesis. Give me 1 minute. Somebody just came in. We state hypothesis. Then we give the significance level. We met significance level for the first time when we were doing confidence interval for the mean and proportion. So we can say that if you're 95% confident, then your significance level alpha will be 5.05. That means you have the probability of committing an error will be 5%. And if you are 90% confident, your significant level, the alpha will be 0.10. That means your probability of committing type 1 error is just 10%. Then we select the sample from the population, collect data, perform the calculations required for the test. Then we reach a conclusion. So we do this for various things. For example, we might be interested in knowing if a particular medication can actually lower the patient's blood pressure. Or does seatbelt really reduce the severity of injuries caused by accidents? Does the public customers prefer a certain color in a new line of fashion? These are the kind of questions we test hypothesis. Does COVID-19 vaccine, is it actually effective? We can also test that. So many things, we can use it. Now, there are two types of hypothesis. We have the null hypothesis and the alternative hypothesis. We use HO to represent the null hypothesis. And we use H1 to represent alternative. Now, null hypothesis simply make a statement about that the value of a population parameter equal to some, claim value or hypothesized value. So for that, we often use equal sign or greater than or equal or less than or equal sign to state null hypothesis. Now, the alternative hypothesis says the opposite of whatever the null hypothesis is saying. So if the null hypothesis says that the mean equals 0, for example, the alternative will say that the mean is not equal. So for an alternative hypothesis, we use not equal, greater than or less than. So you cannot use these symbols for the null hypothesis. And you cannot use the symbol for null hypothesis in the alternative. As you can see here, the null hypothesis involves some kind of equality symbol, either equal or greater than or equal to, or less than or equal to. But the alternative hypothesis is used mainly non-equality symbol, like not equal to, greater than, or less than. Okay. So these are the types of hypothesis. Now, let's see. Okay. For those of you who are just coming, I recommend that you read my announcement so that you know what is due this week, which is including your project. Anyway, types of errors. When we do the hypothesis, that we make error. Anything that human does, there's always a probability of error, and we recognize that. We call it, there are two types of error. The first one is type 1 error. Type 1 error occurs if we reject the null hypothesis when it is true. That means a correct null hypothesis, if you reject it, we have committed a type 1 error. Now, for type 2 error, in this case, we do not reject the null hypothesis when it is false. We say that it's type 2 error. Okay. Now, let's see how this goes. Suppose this is the decision matrix. The decision, please speak up. I don't use text message when I'm teaching, when I'm in the classroom. If you want to have question, ask me. Now, let's say that the null hypothesis is true, but you reject it. You are committed type 1 error. If the null hypothesis is, if it is false and you rejected it, see, false, and you rejected it, you have made a correct decision. Okay. Now, if the null hypothesis is true and you do not reject it, you have made a correct decision. Correct decision. Okay. Now, if the null hypothesis is false and you did not reject it, you have committed what is called type 2 error. Give me 1 minute. Let me send this. Okay. Now, if it is if the hypothesis is false and you do not reject HO, you're committed type 2 error. Now let us see how this thing work. Okay. Says, let's say that I'll use the legal system to explain this. Let's say in a legal system, let's say that a defendant, maybe somebody who committed a crime, is brought to the court for jury trial, jury trial by jury, very popular in US. And the hypothesis testing can be likened to that jury trial. So there are in a jury trial, there are 4 possibilities. The defendant is guilty, the defendant is innocent, the defendant is convicted, the defendant is not convicted. See, these are the 4 possibilities in a jury trial. And we can use this hypothesis testing situation to analyze this. First of all, our null hypothesis, that we state our hypothesis. I think I'm gonna have to move this down. Our null hypothesis can be that the defendant is innocent. The alternative is that the defendant is guilty. Good. If the null hypothesis is true, that is, if the defendant is innocent, and we reject the null hypothesis, rejecting the null hypothesis means convicting the defendant. So if the defendant is innocent, which means that the null hypothesis is true, and we reject it, which means that we convicted the defendant. even though he's innocent. We have committed type 1 error. And you know, this kind of thing happens sometimes. Recently, DNA that have shown that many people that were sent to jail years ago due to based on witness statements, we are now found to be not guilty because DNA tests have, you know, liberated them. And that kind of thing is a type 1 error. Now, if the defendant is guilty, that means HO is false. And he will reject it. That means we convict the defendant. That means we are committed, we have made the correct decision. Now, if the defendant is innocent, which means HO is true, and we did not convict the defendant, we have made the correct decision. Okay. Now, if the defendant is guilty, which is HO false, and we do not reject HO, that means we didn't acquit, we acquitted the defendant. We committed type 2 error. See, so that's this. That will give you an idea of what hypothesis test is. Any questions so far? Any question?
No.
Good, very good, good. Now we can now move on to how to state hypothesis. Very important. In a hypothesis testing question, you ask a question, but you graded on mainly 4 things. First of all, whether you stated your hypothesis correctly, whether you identified, do the test statistics, your decision, and your conclusion. So let's start with how to state hypothesis. Okay. It says, the question here says, state the null and the alternative hypothesis for these claims here. It says a researcher wishes to, a researcher thinks that if expectant mothers use vitamin pills, the birth weight of the babies will increase. The average birth weight of the population is 8.6 pounds. So let us state this hypothesis using, because it says average. So remember, mean is the symbol for average. Mean. So I'll take you back there. Okay. Now, when you look at the question again, you see the average. So HO, let's put HO and H1. Okay. You see the average age for the population is 8.6 pounds. Is means equal. So that means HO mean equal 8.6 pounds. And that is the what he says, that is 8.6 pounds. But this researcher think that if they use vitamin pills, the birth weight will increase. So that is his claim, that is that the birth weight will increase. So that means mean, okay, mean will be greater than, I put the symbol. Mean will be greater than 8.6 pounds. And that is the researcher's claim, their claim. Okay. So you can see that it's greater than, if you are asked to put this, this is like a 1-tail test. 1-tail, okay, test. Because when you put this, you see that it is going on the right side, it is pointing on the right. So it's 1-tail. Okay, 1-tail test. We'll come to that in a few minutes when we do one tail and two tail tests. Because one tail, you can see from here, it is pointing on the right side, greater than. So you call it one tail or right tail test. Okay, so you have stated the hypothesis that the mean is greater than 8.6 pounds, and another example. It says an engineer claimed that the mean number of defects can be decreased in the manufacturing process for compact discs by using robots instead of human beings for certain tasks. The mean number of defective discs per 1,000 is 18. So let's state the hypothesis. Okay, solution. Okay, HO, okay, and H1. Okay, he said that the engineer claimed that the mean number of defects can be decreased in the manufacturing process for compact disc by using robots instead of human beings for certain tasks. The mean number of defective discs is 18. So HO is means equal, and equal can only be used on the null hypothesis. So you have mean equal 18, but he said that can be decreased. See, can be decreased. See, so that means mean decrease can only be used in the alternative. Is less than 18, and that is his claim. Again, this is a one tail test. We can call it left tail test. Okay, because it's on the left tail. One tailed test is pointing. So you can see the claim is pointing to the left side. Okay. Any question on this? Any question? Okay. So let's try another one. It said a psychologist feel that playing soft music during a test will change the result of the test. Psychologists. Yeah. Another way you can state this hypothesis, you can also state it in this form. So that the claim, the first one we does see another method. Both of them are correct, really. Method 2. Okay, you can say complete this form. HO and H1. So we have H1. It is claimed that the average birth weight. He said that if a spectrum mother use vitamin period, the birth weight of their babies will increase. So you see, increase, which means greater than, and can be used only here. Okay, mean greater than 8.6 pounds, which is the claim. Okay, now the now will say the opposite of the alternative, which means that mean is less than 8.6 pounds. But you cannot use less than symbol in the alternate in the null. You can only use less than or equal to symbol. Okay, 8.6 pounds. See, both methods are correct. Some textbooks use this method, some use this, but they are all equally correct. The same thing applies here. The claim first, mean is less than 18, then this can be greater than. But because you cannot use greater than here, you use, so let's say, let me write the method 2 here. So you can see, you can know both method. I prefer method 2, but that doesn't mean that method 1 is incorrect. It is still correct. You can say HO, okay, and H1. Yeah. Here it says that the engineer claimed that the mean number of defects can be decreased. Decrease can only be used in the alternative. So you have mean less than, okay, less than 18, okay, 18, which is the claim. Then here you can do the opposite, but no, not an alternative. They say the opposite of each other. In that case, you can say mean is greater than 18, but you cannot use greater than symbol in the null hypothesis. You can only use the greater than or equal to symbol in the null hypothesis. So, like I said, both methods are correct, but like some books use this, some books use that. I prefer this one, but that doesn't mean that if you use this method that you are wrong, you're still correct. Question on that? Any question on that? Solution. Okay. So a psychologist feel that playing soft music during a test will change the result of the test. The psychologist is not sure whether the grades will be higher or lower. In the past, the mean scores was 73. So, so he's not sure that whether it is less than or greater than. So, but he said that it will change. Change means not equal to. So HO and H1. Okay. So he claimed that it will change the result of the test. That means mean not equal to 73. For say in the past, the mean score is 73. Not equal to 73. That means it will change. Claim. Then the now is mean equal to 73. Now you notice that in all this example I gave here, the claim is on the alternative. It's not always the case. Sometimes the claim can be in the null hypothesis. It can be either way. Just a coincidence that it's all done in the alternative here. For example, look at this example. This is percent. So you remember, hypothesis testing is about a population parameter, and percent or proportion is a population parameter, because here I say at least 45% of senior citizens were hearing aids. Now it didn't say mean, so you cannot use this mean symbol. So you're gonna use the proportion symbol, HO and H1. At least means greater than or equal to. That's what it means. And you can only use greater than or equal to in the alternative hypothesis. So you're gonna have P at least 45%. Okay. 45% is the claim. Actually, my mistake. Sorry about that. So at least you can only use greater than or equal to in the null hypothesis. You can't use it in the alternative. So you say at least greater than or equal to means P. Sorry, at least for 5% of senior citizens, we are hearing aid. It means greater than or equal to. And you can only use greater than or equal to in the null hypothesis. So you have P greater than or equal to 45%. So as you can see in this one, that the claim is now in the null hypothesis. Null hypothesis. It has nothing to do with the parameter you're testing. Then the opposite will be, the alternative will be P less than or equal to. But you cannot use less than or equal to here. You can only use less than or greater than. So you have P less than 45%. Okay. So that is the okay. So let's do another one. It says here, let's number 5. You can try number 5 as a practice. Let's do one more here. Just one more. It says the average income of accountants is 51,000. Solution. Okay. HO and H1. So we have, see, the average income is 45,000. So it means equal to, and you can only use equal sign in the null hypothesis. So it means that mean equals 51,000. 51,497, and that is your claim right there. So again, you can see that the claim now is in the null hypothesis. Here, alternative say the opposite. Mean is not equal to 51,497. Okay. Any questions so far? Any question? Okay, good. So you can try number 5 and number 7 as a practice. Let us take a quick look at the terms used for testing hypothesis. First is the significance level. Level of significance is we use alpha to denote level of significance. It is called the probability of committing type 1 error. I have already explained what type 1 and type 2 error is. Okay. So the probability of type 1 error is the alpha, which is the level of significance. Critical region is another way of explaining is that it means that it is the rejection region. When something falls in the rejection region, if your answer fell in the rejection region, then you reject a null hypothesis. If your answer falls outside the rejection region, it is now, you don't reject the null hypothesis. And critical value is the cutoff mark from the rejection, between the rejection region and the acceptance region. Now, two-tailed tests. So when a two-tailed, if you look at this diagram, this shaded place are the critical region or the rejection region. I'll make sure you're seeing this. Yep, you're seeing it. Here, this in between here is the acceptance region. If your answer falls in the acceptance region, you don't reject HO. But if they fall in this critical region, you reject. So because there are two of them here, one on the left, one on the right, we call it a two-tailed test. Some tests are there like that. Now, one-tailed test is when they fall in one region. This one fall only in there's only one rejection region, which is on the left side. We call it left-tailed or one-tailed test. This is the critical region. If your answer falls here, you reject. And this is the critical value, the value that cut off the critical region from the acceptance region, Z negative alpha. Now, critical region can fall on the right side, it becomes a right-tailed test. Critical values will be here, which is a Z alpha. If your answer falls on this region, you reject the null hypothesis. If it falls in the acceptance region, you don't reject. So now, let me we only have 4 minutes, so we'll come back next. We start doing the actual hypothesis testing. So, but if it times us out, wait for 10 minutes, log back in using the same link that you used to log in now. Now, those of you who come late, I want to use this remaining 4 minutes to just show you a few things before we are timed out, okay? Now, for this week, next week will be our last week. This is my announcement. Start reading chapter 9. The assignment will be classwork 13, which I will put after the class. Homework 9. And of course, you know how to locate your homework. Then final project. All assignments for this week are due on 11th, except the final project. Final project is due on 17th. But I want you to start working on it because there's many things you need to do on that. If you click on it to locate the final project, you click on the assignment section, and then you can scroll down where you have Excel assignments. See, final project is a part of the Excel assignments. This is what it is. You click on it, it will open. You can download it. Okay, you can download it. It's a Word document, so you can download it and type on it. Type your answers. Follow the instructions and complete all this. If you use Excel, upload the Excel file too. Put the answers here, but upload the Excel file too. Okay, chart. You can make your chart in Excel and paste it here, so long as you download it, and so on and so forth. When you finish, you can then upload it here. And from your own side, it will show you that upload. So if you like, you can finish it this week, upload it. If you like, you can wait for next week. Then the final exam, I'll make it available on next week. So you can take your final exam and then we're done. Next week, we have a class next week. And that will be our final class on regression. And then once you finish, you can now do your homework and final exam and submit. And that's it. Yeah?
Professor, will you open up any past assignments, like if we needed to complete it to help our grade?
It depends on that. I do it individually based on attendance. If your attendance is up to 60%, then you can request, not all the assignments, some of them.
Okay.
If your attendance is not up to 60%, you can't, because you cannot disappear for the whole class, then reappear and then asking for, then start requesting for makeup for. I reserve that privilege for those who have good attendance. Okay.
Mm-hmm. Thank you.
You're welcome. Yeah. Any other question before we are timed out? Okay, very good. So remember, wait for 10 minutes after we are timed out, then log back in so that we can work on, do the actual hypothesis testing. Yeah.